Now see here, experimental determination of gravitational constant, that is capital G. So value of capital G can be determined by this experiment. This is known as also Cavendish experiment, Cavendish apparatus. So now see here, in this case here there is a thin rod AB. At this end of this rod there are the two small lead spheres having masses m and m, and now this rod is suspended by a thin wire, and there are the two big spheres like S1 and S2 of masses capital M. These two masses are placed opposite to this each other, like B is here and mass S2 is placed over here, and then the A is here, mass S1 is placed over here. Now see, the distance between small m, this capital M is a small d, similarly here, and the length of the rod is suppose L, length of AB rod is L. So because of this M and capital M, there is gravitational force and there is also gravitational force, but this gravitational force is equal to actually Gm m upon d square. This is equal in magnitude but opposite in direction. So the net force on the rod is 0, but these two forces are acting along the different line of action. So they are producing torque, and that torque is known as gravitational torque. So we can calculate gravitational torque. Gravitational torque tau is equal to G m upon d square into L. So this is the gravitational torque. As this rod rotates, so there is a wire here, wire used for suspension, that also gets twisted, and there is a torque in this wire. That torque is known as restoring torque. Suppose for unit restoring torque per unit twist, B, suppose I can write here the K. So for the twist theta, restoring torque can be written is equal to K theta. So if there is a twist theta, so the restoring torque can be written K theta. K can be known as torsional constant, or you can say restoring torque per unit twist. In equilibrium, these two torques will be equal. So if you are taking these two torques are equal, then you can write here K theta is equal to Gm m upon d square into L, and you can calculate G is equal to K theta d square upon here m into m L. So if you know this L, small m, and this is here the capital M, the mass of the spheres are known to us, already we have taken this K, theta and d, then we can calculate the value of G, and this value of G comes 6.67 into 10 raised to power minus 11 Newton meter square per kg square. Now see this example, actually based on the superposition of the gravitational force. There are three masses A, small m, placed at the vertices of triangle A, B and C, and there is mass 2m placed at O, that is a centroid. Now you have to find out total gravitational force acting on this mass. So there are three forces acting. Due to A, this is acting this side, that is here FOA. So FOA is acting this side, FOC is acting this side, and FOB is acting this side. So there are three forces. And now if I take this point origin, and this we take as a y axis and this we take as x axis. So now this is x and this is y axis. So obviously this side is here the negative y, this is the negative x. This angle is 30 degree and this angle is 30 degree. Now we have to find total force on the mass 2m placed at O. So just we first solve x component. So first we can write here magnitude of FOA is equal to magnitude of FOB is equal to magnitude of FOC, that is equal to Gm into 2m divided by OA square. And now see here, OA is equal to OB is equal to OC. So, all these forces are equal. Let us solve first x component. If you are taking x component of these forces, see here, FOC is this side, it has got the 2 component, x component is along this side, that is FOC cos 30 here I cap plus. Similarly, FOB, its x component is FOB cos 30 minus I cap, because it is going to this side. These are the 2 only x components. So, FOC and FOB are equal, cos 30 are equal. So, obviously net force will be 0. So, net force along x axis is equal to here 0. Similarly, we can take the total force on the y axis. So, if I take y axis is here, we will be writing here FOA, that is J cap, I am talking about this force, plus downside. So, y component of FOC, so that is FOC sin 30 minus J cap, and similarly FOB sin 30 minus J cap. So, these are the forces along y axis. Now, we can solve all these forces here. As we know, FOA, FOC and FOB all are equal. Here this is negative, so sin 30 is 1 by 2. So, if you place the value of sin 30 and sin 30, you will be getting here equal to FOC, and that is a minus FOC, that will cancel out by OA. So, you will be getting FOA is also 0. So, the net force acting on the particle of mass 2m placed at O is 0. But take care here, you can put all these value and solve the step.